morning, everyone. Thanks for being here. I'm happy to be here, actually. So I'm Matteo Cinelli. I'm an assistant professor at the Department of Computer Science at Sapienza University of Rome. And I'm going to talk about echo chamber and polarization in online social media. This talk will also involve networks, which, as we said 2 minutes ago, are matrices, so a matrix, but let's say in a more mathematical sense. So, I don't know what's going on here. Okay, so from time to time I will look here because there is another screen, but actually sometimes I will have 2 points, so I will come here, okay? So first of all, I need to give credits to the people I work with. I'm part of the Center of Data Science and Complexity for Society, which involve all these people. We have also former members, but they're not represented here. The team is led by Walter Quattrociocchi, and we are working on social media, polarization, echo chamber, and related phenomenon. Actually, our main focuses of research are the spreading of misinformation. So we have some studies about the spreading of this phenomenon and how this affects people, especially on social media. We studied a lot the theme of infodemic when it happened just right after actually during the COVID pandemic. Another topic that we study a lot is the spreading of antisocial behavior and toxicity in online conversation. And lastly, we study segregation and echo chamber online. And this is the topic I will talk to you about. So, okay, the process of information consumption in online social media is driven by 2 main factors. The first are human biases in information consumption, and especially the confirmation bias or selective exposure, which is the tendency to seek out for consonant information and avoiding dissonant information. The fact of studying selective exposure without using online browsing data, so browser tracking or survey data, is very hard. So it's something that is hard to do using social media data, but still we can find some proxies. In a study that we ran a few years ago, we downloaded some Facebook data using the Facebook Graph API that now are unavailable, unfortunately. And essentially, we downloaded 50,000 Facebook posts from a huge set of news outlets, so almost 600 Facebook pages that were listed by the Europe Media Monitor. And the reaction to the post of these Facebook pages were involving about 14 million Facebook users in a time window from 2010 to 2015. What you can see in the top graph is that if we plot the average number of pages where users put a like compared to their activity, we see that we kind of reach a saturation point. So regardless their online activity, the number of pages that they actually interact with and follow is kind of constant and around 10. So this means that regardless our activity, we don't consume information from a very wide set of sources. When it comes to topics that are in the bottom graph, to cluster the posts into topic, we use a topic modeling algorithm. We see that users tend to span many topics. So the idea is that users consume information from a very narrow set of sources, but they're still consuming information considering a wide set of topics. So we wanted to go more in depth with this analysis, so beyond these 2 graphs. And so, we decided to measure heterogeneity in content consumption. In order to do this, we decided to compute the Gini coefficient, which is a well-known heterogeneity index in economics, but there are alternatives like Shannon's entropy and others. To compute how heterogeneous it was, the distribution of likes of users. So in this example, we see that the user A, for instance, concentrates the activity on just one channel. So he puts, for instance, 50 likes on the CNN page. And so it gets a very high Gini coefficient. So it means it's liking pattern and in some sense endorsement pattern is very heterogeneous. In the case of user B, we see something very different, where the user B is homogeneous in terms of news consumption, and so it gets a Gini index actually of 0, okay? So what we can do next is to plot the distribution of the Gini index, so of the heterogeneity in user consumption, against their activity measured in terms of number of likes. If you look at the left graph, you see what we get from real data. What is interesting there is that we find some user, actually many users, the color scale is logarithmic, that have a very high heterogeneity in content consumption. So the top left part of the graph. What happens is that if we randomize the liking patterns of users, so if we imagine that users don't put likes following a certain pattern, but they just do this at random, what we see is that the very high selective exposure, I call this selective exposure, but actually heterogeneity in content consumption disappears, and also the very low. So it means that the fact that users interact with a very narrow set of pages is something that is very far from being a random effect. It's actually that it's really something that characterizes well our data. Okay, so I was talking now about the first element that determines consumption of information on online social media, so our bias in information consumption. The second element are algorithmic recommendations, so the role of recommendation systems. So here we have two examples about the role of information recommendation systems. So the first is actually a communication happened in 2015 by Facebook, where they were announcing a modification of their newsfeed algorithm. What they say is that the goal of the newsfeed is to show people the stories that are most relevant for them. So the idea is to craft their timeline based on what they like. The second example is about the experience of a journalist working at the New York Times, who was conducting some journalistic research about Trump and essentially was looking some videos. What happened is that she finished in this kind of rabbit hole where she was essentially suggested white supremacists and racists and in some sense disturbing content. So this is some empirical evidence about the role of algorithm in let's say social media usage. So I'm sorry that this is a big cut, but anyway, so the idea is that the role of selective exposure or confirmation bias, as you want, and recommendation algorithm combined can lead to the emergence of echo chambers. Echo chambers are community of users in which pre-existing opinion and belief get reinforced only due to the interaction with like-minded peers. So this was actually, the dog was shaking, but this is a PDF presentation, so it's not happening. So in any case, these two elements combined may lead to the emergence of echo chambers. Okay, so this is something that for some people may sound trivial, but actually may not to the others. So why do we need network to search for echo chambers? So if we look at this example, we have the distribution of the opinion of users. You may see that this distribution is bimodal. So we have two opinions, for instance, cat lovers and dog lovers, and they are very separated. So one may say, okay, this is a polarized situation and there is a segregation in this case. But actually, it's not the case because this strongly depends on the underlying networks. Indeed, if we keep in mind this distribution and we see the underlying networks, there may be many networks that can generate this distribution of opinions. So we may have, in the first case, a very well mixed network where we have essentially no separation, or we may have two separated opinions, but still people communicating with each other, and we may have more segregated spaces, like echo chamber or extreme polarization. So the idea is just looking at opinion distribution is not enough. We should also look at the network underlying the process. So indeed, this is what we actually did in a study where we collected data from 4 social media platforms, Facebook, Twitter, Reddit, and Gab. I will talk later about Gab. And I mean, I guess you all know Facebook and Twitter. Perhaps Reddit is less famous, but it's still a very used website which is based on communities of interest, so it resembles an old forum. And then we have Gab. So what we did is we collected more than 100 million unique contacts. So we have a data set with 100 million rows, including posts, replies, tweets, and all this kind of stuff. And then we had to do 2 things in order to test the presence of echo chambers. The first was estimating the leaning, so the opinion of the users. And this was done by their endorsement pattern towards pages or news outlets. And then we need to have the interaction network that we estimating using their co-commenting pattern. So just to, I mean, we will go in detail into this concept. So first example, how we compute the leaning of users. So imagine we have these 5 users and our let's say opinion space goes from -1 to 1, where -1 is I am a cat lover and +1 I am a dog lover. So the first guy actually likes more dogs than cats, okay? So I expect him to be more on the right side of the plot, so closer to +1. How do we compute actually the leaning of the first person? So if we assume that the dog token has value 1 and the cat token has values -1, we simply compute the average over cats and dogs. So we sum dogs, so we go up to 3, we subtract 1, so we have 2 and divide it by 4, and the guy is exactly at 0.5. Okay, so we repeat the same thing for the second girl, which is balanced between dogs and cats, and actually she's in 0. The third guy is completely cat lover, so he's in -1. The third person is completely dog lover, so he's in +1. And the fifth guy actually doesn't care. He likes crabs and lobsters, and so he's not represented in the opinion space. So this is just, let's say, a silly example of how it works, but we can easily substitute cats and dogs with pro-vax or anti-vax opinion, okay? So this is the first thing that we do. So after that, we see the commenting pattern of people with cats pages and dog pages. Okay, I'm saying cats and dogs, but it's not actually cats and dogs. So the first 2 people comment something in terms of text to the content P posted by the cat page, while the other people comment the content Q related to the dog page. What we get is that we can model this commenting pattern as a network, which is called a bipartite network, in which we have a link whenever a person comments a certain page. So in this case, we get this bipartite network, and then we can project this network, obtaining a co-commenting network. What happens here is that 2 people are connected if they both commented the same page. So we see that the 2 people that commented the cat page are interconnected, and the 3 people that commented on the dog page are all interconnected. The guy who commented only on the cat page is not connected to the others. So with this, let's say, very simple representation that actually is quite harder in terms of mathematical computation, we can get the 2 ingredients that we need to measure echo chambers. So another thing that we have to do, and this is very important, is considering your opinion, so your leaning and the network in which you are embedded, what do you see on average? What does your neighbor think on average? So, for instance, for the first guy, he's connected to two people, the red-haired lady that has opinion 0, and the gray-haired lady that has opinion 1. And so, on average, this guy sees an opinion that is 0.5. Okay, so he's exposed to an opinion that in general is 0.5. And his opinion is again 0.5. The red-haired girl, she has opinion 0, and she's connected to 3 people. So she's kind of neutral between cats and dogs, but on average, what she sees due to her neighborhood is skewed toward dog lovers, so it's positive, okay? So essentially what we are doing here, we are essentially taking into account the opinion of a person and then computed the average opinion of the people the person is connected to. So essentially exploding this procedure to different data sets, we get some plots like these ones. So I will explain you first the more trivial of those, which is the one on the bottom left. So this is the case of Facebook vaccines, where you see that you have the -1 side, which is related to anti-vax people, and I can understand this because they are less than pro-vax people on the right side. So on the x-axis, you have the opinion of users. So you see that there are essentially 2 opinions here, pro-vax and anti-vax, obtaining by the liking pattern of users. And what we see on the y-axis is the average opinion of the neighborhood, so of the people they are connected to. What we see here is that is something that is pretty far from being homogeneous, because actually if I am anti-vax, so my opinion is -1, on average my neighborhood will have the same opinion. So in this case, where we have this controversial topic and dichotomous dynamic, we observe that there is a strong segregation. We see something similar for what concerns the debate about abortion on Twitter, while the situation is quite different when we investigate Reddit, especially the subreddit about politics, where we see that users are kind all together in the same bubble. And the last case, so bottom right, is Gab, which we will discuss. So actually, I guess it's here. Yeah. So Gab is a very special case of a social media that resembles Twitter and is a right-wing extremist social media, which is kind of popular in the USA. And what we see here, indeed, is that if the individual leaning is -1 means being left-wing and 1 means being right-wing, what we see here is that most of people are skewed towards the right wing. So there is a unique opinion, but still there is a small bubble to the left, meaning that there is some, let's say, left-wing center content happening on this social media. So this is kind of a limit case where we are puzzled if we can call this an echo chamber, because actually looking at this graph it isn't, because we just have one blob. But the case of Gab is special because Gab is, let's say, the white supremacist and kind of the house of free speech, as they define themselves, that was born as a reply to Twitter banning. So it's a whole platform that kind of separated from Twitter and created their own safe space. What, sorry? This is Facebook vaccines. I'm sorry because the left, I mean, the labels are cut because of this. Okay, so for going further from that analysis, we observed something similar also in the case of the COVID-19 pandemic considering YouTube data. So in this case, on the x-axis, we have the individual leaning of users ranging from left to right. And we see that there is some separation in this blob so that essentially people are interconnected with like-minded peers. And this happens on the left graph. While if we look at the right graph, where we, let's say, again, try a random model where we randomize the preference and liking patterns of users, we see that this effect kind of disappear. So again, what happens is that humans are not interacting and not, let's say, exchanging opinion with others at random, but there is some sort of selective process happening here. So going back to the first case, here we implemented some graph clustering, or if you want, community detection algorithm on the network. And then we computed, so what this algorithm do is they take as input the network and they compute communities. So they compute separated group of users inside the network. So what you get is a clustering of people and then grouped into communities. And then we computed here the average leaning of the people inside the communities. So in the case of Facebook vaccines, which is again here, you see that the different communities are actually kind of different in terms of average leanings. So we see that there are some communities of relatively big size that are pro-vax, a small community, actually not so small community, which is kind of in the middle, and then a wide set of communities that are anti-vax. So what we can see here is that the echo chambers phenomenon is has actually some inner segregation inside, so that the two blobs that we were seeing before are actually very scattered inside. So on top of that, we repeated the same clustering algorithm for other cases, so the three other cases I was talking about, and especially we see the situation is more nuanced in the case of Twitter, while in the case of the debate about politics on Reddit, communities are mostly left-center, while in the case of Gab, the situation is quite different, and the communities are more skewed toward the right. What happens? So, okay. Now, what we wanted to do, since we were comparing different topics, is to compare actually two different social media considering the same topic. So here we were considering news consumption on Facebook, which is on the left, and on Reddit, which is on the right. So again, we have this set of users interacting with pages. These pages have a political label. The political labeling is provided by independent news rating agencies. And so we can compute the leaning of the users and via their co-commenting pattern, the network of interaction. What we see here is that the situation between Facebook and Reddit is very different. And actually, in the case of Facebook, we have some very kind of separated blob, while in the case of Reddit, we have just a unique, let's say, opinion actually scattered around -0.5, and the same thing more or less happens in terms of neighborhood opinion. So what does it mean? Is that actually the situation between these two social media is very different. And what one of the things that is very different in terms of these two social media, I mean, is there for sure the user base, but also how the recommendation algorithm work. And so one could in some sense speculate and argue that the role of the news feed implemented in Facebook may have an effect on what happens on the social media. At the time, also, it's important to remark that Reddit was kind of implementing a feed algorithm that could be tuned by the user. So you could say, I want to say this first and this second, so I want a ranking that is customized for me. So users could actually choose how to tune what they wanted to see. Okay, so Based on the, let's say, empirical evidence that I showed you about echo chambers and on the, let's say, our intuition of the phenomenon that drives the emergence of echo chamber, which are biases in information consumption. So if you want selective exposure and the effect of algorithm, we decided to provide a model for the emergence of echo chamber. And the idea is to not just provide a model, but provide a model that we can compare against data. So having models that can be it's not working. Yeah, okay. Okay, welcome to the matrix. No, so the idea is that it was providing models that can actually can be compared against data. Okay, for sure we are not the first that provide an information, let's say an opinion dynamic models that reproduce echo chamber, but I mean we are the first that try to see what happens with the data and actually to compare to previous models. So I will try to be, let's say, easy on this. There is a bit more math. I'm sorry, it's early morning. Okay, so in our model, again, users are embedded in a weighted network. What is a weighted network? A network in which each link, okay, so each connection has a different weight. So not all the connections are the same. And users have a certain opinion in a range that goes from 0 to 1. And this can be about any topic. We are not interested about which topic, it's a model. On top of that, we have three main parameters. The first parameter of the model is the opinion space accessible to a given users, and we call this parameter the timeline. So what actually can the user see in the opinion space? So let's say on the timeline. The second parameter is beta, which is the user attitude to ignore what is proposed by the algorithm and eventually to seek out for more extreme stuff. And we call this parameter the bias or the shift. Actually, I will call this the bias. And the third parameter is the reinforcement process of link, so the influence. So the idea that if I interact constantly with something, our bond, our social tie will be reinforced. Okay, so what the user see in the timeline is ruled by this equation, which is the user opinion minus the radius, so what the user see, plus the bias. And the user opinion plus the radius plus the bias. So in this very simple example, the user has opinion 0.65, has no bias, and has a radius of 0.2, so the user sees everything in the range 0.45, 0.85, which means on this network, the user sees only the green links and not what are the red links. So if we change a bit this parameter and introduce a bias of the users, what happens is that the effect of the timeline is cancelled out and the users seeks only for more extreme stuff. And in this case, the user would see only what the opinion of the green users. Actually, sees only the opinion of users connected via green links. So this means that is looking out for more extreme stuff. So the model works using 4 steps. So in the first, the users become active with a certain probability, distribution, which is sigma, and the users become active with probability sigma I. And then the users visualizes the suitable neighbors, so the neighbors that are like-minded in some sense, according to the equation I was explaining before. After that, the users updates his or her opinion according to his previous opinion plus a parameter delta, which is the average opinion of the users, and is a weighted average based on the weights of the links on the interconnection. After that, there is a step in which the strength of the links get updated according to a certain parameter and according to the users, to the connection, active connection of the users. So considering the model, we start from, let's say, an initialization phase that we call pluralism, in which the whole opinion space is represented, and so on average what the user, which is, you can see on the x-axis, and what the users see on average is 0.5, because there is the whole opinion space represented in this kind of random network. From these cases, depending on the parameter that we choose, we may reach different situations. The first is consensus, in which we have only one opinion. The second is fragmentation, in which, I mean, the opinion is separated, but still the users see a kind of different set of opinions. And the last case is polarization of echo chamber, in which we have two very well separated opinions. So now what we wanted to do is to compare our model against the data. In order to do this, we considered the realization of this wide set of simulation that we did that has the lowest Jensen-Shannon divergence, which is an information theoretic quantity that, and what does it mean? If it is low, then the data are very similar to the model is very similar to the data. If it is high, then the model is different to the data. In this case, we obtain these values that are relatively low, but, and this is the result of the best realization of our model, but then what we want to do is to compare actually our performance against the data, because per se it doesn't count much. So, okay, in this plot we see that if we consider the top 5% of the realization, the parameters are actually meaningful, because the 4 social media platforms are kind of having a different parameter set. So it means that each parameter is capturing an aspect of the data. And here we compare with the first model that was published in a physics journal, in physics review letters by Bauman et al. And we see that this model is kind of different from ours. So we are not comparing our model against another one, but rather we are comparing all the models against the data computing this quantity, that these models kind of improved the situation in the case of Reddit. Then we had also another model published in Information Sciences, and this model actually performs much better than ours in the case of Twitter, and improves the performance of the models in terms of how the model can reproduce the data in the case of Reddit. In the case of Reddit. So, okay. So the idea is that, oh, sorry, I can skip this one, is that, let's say, along this rather mathematical journey, we provided some evidence for the fact, for the presence of echo chambers, so the fact that echo chambers are present in, let's say, online data, and we see that there are clear differences across different platforms. One may argue that these differences are kind of algorithmic driven, but I mean, this is so far just a speculation, because we cannot measure the timeline of the users without, I don't know, experiments or let's say online browsing data, but still in that case, there might be some bias. I mean, it's kind of complicated. I would like to discuss the case of Gab, because it's kind of a controversial thing. So Gab is made up of users who migrated from other platforms, mostly Twitter, and they are kind of, you know, a specific audience. This relates to another problem we are working about, which is the migration of users. So in this plot, you may see on the y-axis the toxicity of user during a migration from one social media, from Reddit to another social media, which is an extreme one, which is called Vote. And if you see, I'm sorry that the graph is cut, is that when users migrate before the ban, so before the ban and 6 months and 1.5 years after the ban, their toxicity grows. So this means that banning people, this practice of deplatforming, is kind of working towards creating a more toxic environment. So one may argue, okay, but is Gab an echo chamber? And so if you are arguing that Gab is a right-wing social media, there is some part of the opinion space around zero. The idea derives, a possible justification derives from this paper, which states that outgroup animosity drives engagement. So in a social media where people are right-wing, what can happen is that still left-leaning articles and this kind of stuff can be published, but in a negative tone, okay? So perhaps this kind of deplatforming and rise of this platform may lead to the emergence of actually what we could call echo platform. So not just, let's say, separated opinion space within a social media, but new social media platforms that are actually homogeneous in terms of opinions. And this, we may have example, for instance, Gab, but also what happened with The Truth, the social media driven from, run by Trump, which is actually called The Truth because he wanted to select some sort of people, in which I expect that the opinion space will be very skewed toward the right. So we all know that there is some criticism about echo chamber. One of the main arguments I found about this criticism is that exposure to a diverse set of point of view and echo chambers cannot exist. But actually, for how we measure echo chamber, they are based on interaction patterns. So we don't know what the users actually see, but we can measure what the users interact with. So the idea is that perhaps they may see a wider set of sources that we measure, but actually they are interacting with specific set of sources. So also as a conclusion, I would like to talk about these two unpopular opinions. One is, let's say, pointed out is in this science paper. It actually is a perspective that is called the Misinformation Machine. Is that in this field is kind of happening quite often that there are contrasting results. And this happens also in sets where the methodological conditions are let's say, robust. So, I mean, there was the case in which there were two important papers measuring the presence of bot in 2016 election, and one paper was finding evidence for the effect of bots on the outcome of the election, and another one was not finding evidence. So this is something that is happening, and I guess this is one of the challenges to address in this field. So I wanted to lastly talk about solutions. So in my opinion, the solutions are kind of hard to find for these problems. And one solution that I found pretty interesting to solve the problem of polarization, misinformation, and online segregation in general is what is called pre-banking. So the idea to preventively expose and inoculate people to let's say, bad practices and potential misinformation strategies on social media. The role of pre-banking is kind of part of a bigger strand, which is the social media literacy. I found this very interesting project by YouTube, which is called It Pose, where they, considering multiple language, they kind of teach people how, let's say, to avoid misinformation content, recognize it, and let's say using, implementing a more healthy online behavior. And the last thing is, for sure, raising awareness about the bias that we have when we consume information. So lastly, I asked ChatGPT how to solve the problem. And actually, the reply was amazing. So I asked ChatGPT, so this new AI tool, how to solve the problems of online polarization and echo chambers. And ChatGPT said, online polarization and echo chamber are complex issues with no easy solution.
Okay, we are on the same line. One way to approach this problem is to encourage people to engage with diverse viewpoints and sources of information. I guess we all agree. This can be done by promoting critical thinking and media literacy, so far so good, as well as by providing access to a wide set of perspectives on social media platforms and other online communities. Another important step is to address the underlying factors that contribute to echo chambers and polarization, such as the filter bubbles that can arise from personalized algorithms and the spread of misinformation. I mean, it's actually perfect for my viewpoint. This may involve regulatory measures as well as effort to promote transparencies and accountability among online platforms and content creators. So actually, I should have done this year before when I was thinking about possible solutions. Okay, so this is it, and thanks for being here.
Matteo, I thought we would provide evidences for existence of echo chambers for the first time. You disappointed me. It already exists. It has been proven many times. But we're going to offer some original perspectives with the research that we work on.
Sure.
And the GPT-3 really amazed me. So it offered some solutions that we thought that would be the best for these issues. Any questions for our keynote lecture? Now, this thought-provoking presentation. Yes, please.
Yeah, it's on. Okay. Walid Al-Sakaf from Södertörn University in Sweden. First of all, thank you, Matteo. Very, very enlightening indeed. One area that has been discussed quite a lot recently, usually at the global fact summits where fact checkers come, they meet with companies, platforms such as YouTube and Twitter and Facebook, and they see the human element as fundamental in the pre-bunking stage. And so there is this project by Facebook called Third-Party Fact-Checking Initiative. Not sure if you've heard of it, but it's basically before even having the content published on these platforms, they run an algorithm to detect whether it could be potentially misinformation. And then it marks it for fact checkers manually, through which they do the fact checks in a sponsored program. Afterwards, they demote the content, not remove it, not censor it. They still have it there, but it's less frequently shown. What do you think about such a platform initiative?
Okay, I think I didn't hear of this initiative, which I think is interesting. I'm not sure about it could scale well. I mean, if you have an algorithm processing information and then you have manual checking, and then you have, I mean, there might be some latency in your content being promoted. So what I think is that, I mean, fact checking may be useful in some occasions, but I mean, imagine that people realize that if you are posting something that is anti-vax, your content that get lower in this situation. I mean, I'm afraid that it could backfire very easily. So this kind of solution may be useful, but the risk of backfire is there, and people may further polarize and eventually, as I said, kind of decide to leave the platform. And this is indeed what's happening if we see like a rise in Telegram groups and this kind of more extreme social media, which are niched. I mean, maybe it's not happening for everyone, but we should think to the social cost of extreme polarization. It's not many people, but for sure we see that polarized people are those that are most engaged. So they are producing most content. So it's very interesting for sure. It's good that people, I mean, companies and researchers think to viable solution to resolve the problem of misinformation and let's say polarization in general. But I guess we should be cautious about this.
And also it would help if we knew how the algorithms are set up, because sure, it's like a secret from tech companies.
Yeah, and
Big Brother.
Yeah, doing reverse engineering, or also kind of trying to simulate or provide models that let's say, more tailored to the data is kind of against the code of conduct. So you're always in the gray zone. And so, okay.
Claudia would like to ask another question. The mic will approach to you.
Thank you very much. Thank you, Matteo. That was a really interesting presentation. My question to you is, how do you think echo chambers are any different from what used to happen in the past, where people would buy the same newspaper every day, and which was very often leaning one way or the other, right? So there you could think it as a form, and when you talk about echo platform, we get even closer to that. And I can think 3 possible answers to that, but maybe there are more. I don't know which one is most relevant. Obviously, there is a different. One is granularity. Here we're talking about very specific item of news or information. The other one is scale, the fact that we are talking at a completely different scale compared to buying newspapers. And the other one is factuality. Where do we, the difficult of measuring how much something is a fact has become harder and harder, but maybe there is more, maybe something is more important than other.
Okay, so I think the first 2 ideas are kind of in line with, let's say, my opinion. As the, let's say, business model of information changed with the, let's say, advent of social media, let's say, the idea is that underrepresented opinions and some sort of, certain opinions can find, let's say, a fertile ground to prosperate, and so people can actually interconnect much more than before with people that have a similar leaning. So before I was buying a right-leaning newspaper, and then I was expressing my opinion through voting, and perhaps I was interacting with a few people having the same, let's say, opinion of myself. But now this is scaling up very fastly, and we can connect very easily to, let's say, more extreme and, let's say, more homogeneous people. And so this means that this can scale up, very fastly.
So this is just the presumption that algorithms are set up that way to boost echo chambers to...
Not just algorithm, also the fact that if I have a certain opinion or a certain, I would say a certain opinion about anything, because our, let's say, opinion space is multifaceted. We can see this as a vector more than as a number. Then you can always find something that confirms what you already think. And you may find a very wide group of people thinking the same. Like flat earth society is something actually that doesn't cause much harm, but before you didn't know about people associating for flat earth. So it's something that happened, with the rise of social media, essentially. So it's the fact that you can find like-minded peers very easily and create bigger community and create a very animus group, and eventually this can scale up very badly, as in the Capitol Hill assault, I would say.
But the thing is, the people are usually very lazy, and then they don't go and to the websites or finding these communities. It happens when the algorithm recommends some content to us, and then we glue up to it somehow. That's my opinion. And now Damian would like to ask a question.
This is the question I am afraid of.
Oh no! I actually wanted to say that I really enjoyed your presentation. Thanks a lot. But I do actually have a question about actually the fact that there's a lot of averaging going on. So to estimate the opinion, you basically take an average, and also, if I understood correctly, there's later on to estimate basically the neighborhood. There's some weighted average of the opinions of those you are connected to. And I was wondering whether, conceptually speaking, something that is relatively close to the midpoint of the scale, to 0, whether that actually shouldn't be just okay. So for instance, if I see it a bit more like if you at least get some connection to the other part, that might actually be enough. So the optimum maybe is not 50-50, not necessarily. So I was thinking, what would actually happen to the model if you would have some kind of measure where the more you deviate from the midpoint of that scale, the higher that is actually weighted. So if basically some squared function or whatever it would be, whether that would fundamentally change the results or not, because yeah, I just think that if you are somewhere within some span around the midpoint, that should not concern us that much. It should concern us if you move very much to the extreme. So I wonder whether you have any ideas or thoughts about that.
Well,
Thanks.
yeah, I see your point. It's actually fair. We are actually averaging over the set of content one person actually interacts with, and also over the set of neighbors. For sure, the most worrying cases are those in which you are at the extreme, so where you are kind of trapped. In other cases, I guess that considering different strategies, or considering actually scattering over the mean, so let's say deviation, skewness, whatever from the mean, might actually be beneficial in terms of quantifying the let's say the set of what the users see, of the heterogeneity of the neighbors. For sure, there is some communication, because I mean, it can be denied. The thing is that this communication is much less than random. Okay, so in expectation, you would expect much more. And there is also a problem of balance, as you said. I mean, it doesn't have to be 50-50. What we can do is to provide perhaps models that are not random, because also randomness is a big assumption. Not many things are random in the real life, but are statistical models that are, I mean, the best that we can do. I really agree that we can do a bit better, but this is part of a journey, and I hope to reach the point where we can be considering the scattering, the deviation from random with more appropriate models, and perhaps tune our models to consider these two parameters. I really look forward to do this.
Okay, I guess this is a start of some good collaboration for the future. Thank you, Matteo, for this amazing lecture. Another question, yes.
Sorry, I don't
Please,
know.
Francesco, yes,
Okay,
just a quick one.
Just because it's Francesco.
Okay, then. No, I saw that I was hit by a specific division in Twitter and Facebook about abortion and vax-no-vax dispute. And on Twitter, the dispute about abortion was not so polarized. If I understood well the representation of the distribution of values. I was wondering just to if this difference, because they are both emotionally involving arguments, you know. So abortion and vax-no-vax, they involve you in a, with rage and other feelings. Do you think that depends on the argument, the platform, and I mean, Facebook versus Twitter, or anti-pro-vax versus abortion? And if there is a way to weight emotional involvement in your model?
Those were empirical results. I didn't take into account emotional involvement. It would be an extra step that it would be nice to involve. We developed recently a tone, or let's say conversation tone classifier using a deep learning model. Yeah. And this is something that we should embed. We were trying to use other things like the Perspective API by Google Jigsaw, but it scales pretty badly because API requests and so on. Going back to your question, I guess this is that was, in my opinion, a platform problem. On Twitter, people tend to engage with, I mean, outgroup a lot, because I mean, so let's say fighting is something that is more common to Twitter. But this is maybe common sense. I don't have a mathematical or data-driven explanation for that.
Thank you.
Yeah, sorry, may I do a remark? Yeah, what we do is mostly data-driven. So we take the data and we measure stuff. So then we try to find an explanation for what we see, but sometimes it's very hard to disentangle factors.
Yes, and since you're doing theory, that's a good idea to to make collaboration on this and expand these data, explain them data. Okay, thank you very much, Matteo, and thank you very much for being here. Okay, let's turn to another segment of this